Hello Internet, we are live. Okay, so today we will continue working with Tokenizer, hopefully finish it, make it fully featured, and then continue with parsing statements actually. So parsing the Axiom declaration statements, parsing the theorem proving, and then obtaining the result, the output of the MathAsm file, so to say, which will in fact build the mathematical theory. Okay, so where we left last time was the Tokenizer. Its unit tests are here, which we test various text and then we expect specific tokens to be given back. And before we move with the actual parser, actually the parser is the one who calls and controls the Tokenizer. Before we go there, I would like to a little bit improve that method here, make it a little bit more readable. Because actually this can definitely be improved. So what we have here, first of all we check if we're at the end of the file, and if we are not, we try to parse the thing as a symbol, and if it's not a symbol, we try to parse it as an identifier or a keyword, and if it's neither of those things, we return end of file, which is actually not very correct yet, because there can be other things, like, I think here we should throw an exception actually. If the symbol is an unknown character, maybe an invalid character that does not exist in MathAsm, such as a hash, for example, maybe in that case we should just throw and say, hey, unknown character, illegal character. Maybe actually this would be a good place to start. So if an unexpected character comes, we say we throw unexpected character exception. Yes, exactly. And we say unexpected start of token. And what is the unexpected start of token is your next chart. Okay, let's see how our unit test would react to that. Because I don't think we unit tested it yet. Unexpected characters. Let's see. Why is it so slow? Okay, one test failed, so... But why? Unexpected start of token, and then it lists an empty line. Ah, the empty line, of course. You see, we forgot the empty line. If it's an empty line, then return. Sorry. It's a character. I always do this mistake, not a string. It's a character. We compare characters. You see, too much JavaScript burns your brain. You forget to think rationally. Okay, so that's a character. So if it's not a character, /n, then return end of line. End of line, exactly. Good, you see unit test save your life. You see how beautiful. We did something that broke some feature, we immediately detected it. So, okay, yes, this test is also wrong. In fact, we should get a new line. New line is a token, and then an identifier. So we'll say expect end of line. We don't have it yet, we will create it, no problems. So expect end of file, we have a similar method. These methods are just helpers. It's things that will make our unit test more readable. It's nothing really end of line here. Because we will probably need those things in multiple tests. So Okay, so we expect an end of line and then the identifier hello and then the end of file. So now this should be the sequence of events that happens here. Okay, perfect, we're good. Now let's start building our new feature of throwing when an empty unknown character has been detected. So let's create a unit test and write something and then an expected character like that. Axiom hash. This is not valid, MathAsm. So what do we expect? First we expect identifier, which is called Axiom. Actually, we don't expect an identifier, we expect a keyword. That's a keyword. So write hello, better. Hello and hash. And then the next should throw. So let's write assert that thrown by, the next should throw an exception. We have to define the variable, of course. So tokenizer.next throws, and it throws is instance of unexpected character exception. Yes, this is what we expect, and we expected has message. It should say something like unexpected start of token, right? Yeah, unexpected start of token. Let's say has message starting with or containing, we don't care really. We just have to, the error message has simply to mention that is that. So, should throw on illegal start of token. Let's see. Okay. Yes. Expecting to raise a throwable and it didn't. Of course. Because we expect first, expect the identifier hello. And then, like, the hello is still valid. And the second token that we will try to read, this is the one who should throw. Let's see. Yeah, works. Good. Now we have a blind spot. Yes, we have a blind spot. So the blind spot is that we don't yet know to read numbers. Numbers are still, even though it's like, let's see, end of file, end of line, we handle them. Axiom keyword, all the keywords we handle. You see that's the only one who we don't handle yet. All the others we seem to use already, but okay. So before that, actually, you know what? Small ones can go on the top. Like, let's put that in the beginning. And now we have to say else if. You know what? All this if, else if, we will improve that drastically afterwards. But for now, I want just to finish with the last part, which is the numbers. If next char is number, actually is digit, that's fine. If it's a digit, then we will say to roll back. Yes, we have to roll back to read the number, and this read number. Actually, we only support integers, so we don't. I mean, the language itself does not need anything other than an integer. So the parsing is going to be pretty easy and straightforward. Read number. So we need to create that function. But before we do, let's create a test that fails. Let's play the good test-driven develop game. So we would expect, if MathAsm was working properly, that hello 234 should expect hello and then expect number 234. We don't have this, let's create this. So expect number, the value would be an int. This is actually repetitive code that we would write again and again, and constructs like that make our test more readable. This is the only reason why I do that, because look how easy that reads. Like, these helper methods allow us to write beautiful tests. I think it's of course a matter of taste a little bit, but yeah, that's my taste. So number token, what's your problem? Yeah, it's an int. What's the problem? Oh, unit. No, not a unit. It's an int, not a unit. This was a typo. Okay. So now should be able to read numbers. Yes, import that. And that's our test. Yeah, the way I feel that this reads beautiful is simply, it's easy to read and understand. It's easy for your brain to see that in 5 seconds and understand exactly what's happening. This is what I mean. So it boosts productivity to write code like that, in my experience. Okay. Now, this should fail, and then we should write the code necessary to make it pass. I guess if I do it correctly, that's the idea behind test-driven development. So it fails, of course, because we didn't implement the feature yet. He throws an unexpected character exception, obviously, because that's our fallback if everything else fails. So we will make it now not to fail. This would return true for the character 2, and then we should come inside here, and we should be able to read the whole number until the end of input, or until we meet a non-digit character. Like if we meet something like, for example, that, we should read a dot. Actually, let's leave it like that. Let's leave it with a dot. And then we say expect dot. And then expect end of file. So this would be our script. Hello, 234, dot, end. That's exactly what is written here. So, yeah, read number. Let's go here. Private fun read number. It should return a number, an integer. And so let's do it the old way. Let's create a string builder, and we say while next char is this dot get next char. Can't we do that in Kotlin? Tell me that we can do that in Kotlin. Oh my god, Kotlin. Maybe we can do it that way. Is digit? No. Okay. While true. The old school way. So next char is the next char. And if that's null, break. Yes. And so if the character we just read is a digit, then put it into the builder. Append it. Else just go on. No, else break. What I'm talking about. Else break. If it's not a digit, then we break. It means the number is over. Else break. Let's write it like that. We can do that maybe. Take if it is digit. Isn't it that the same? And then simply do that. Right. Let me think. Okay, we get a character. And if it is still a digit, it's maybe not a digit. If it's not true, yes, that's it. If it's not true, maybe false, maybe null, then break. Oh god, but this is worse. Like, Kotlin offers a lot of syntactic sugar, but sometimes make the thing less understandable. More compact for sure. Then there is some elegance to that, but I want the code to be understandable even from a beginner, as much as possible, of course. And these take question marks. They don't serve that purpose very well. I prefer that, to be honest. So you get the next star or you break. If it's a digit, you append it, else you break. A little bit longer, but I think it reads better than the previous one. Okay, that's it. And then we return builder to string to int. That's what we do. I think that should work. What string? Yeah, create number, of course. So number token, yes, we return a number token. That's what we do. Let's see now if you pass. Hello, number dot end of file. It didn't work. What didn't work? Yes, we need to. Yes, so we have to roll back that guy. So the next attempt to read the character, yes, of course. Of course, this is what we didn't do. So roll back character and then break. Yes, yes. I would like to write also a unit test for directly end of file, because this will trigger. Yeah, let's do that. Should be able to read numbers ending with operator. And so we'll remove that dot and we expect hello 234 end of file. Let's see. Good. Yeah, okay. So now I would like to go back to my promise and try to improve how this method reads, because this is trying to identify various cases of what a symbol can be. So I would take that and extract a method and say get as end of line. And the parameter is the next char, yes. Oh, what? What? Who? What? No. I didn't want that to be part of the method name. Oh my god. Of course not. Of course this is not what I meant. God. IntelliJ sometimes. Okay. Get as end of line. So this would return, it's not a boolean, no, it's not a boolean, it's the token. End of line token. So return the end of line, else return null. Yes, okay, let's extract here, it makes sense. Return if that else null. Else. You know, I prefer the ternary operator. Kotlin was not smart to remove it. Sometimes for long expressions, this if-else is better, but for small expressions, compact ones, this is just waste of characters, sorry. And this and the parentheses, oh god, you over-engineered it. Ternary operator was so simple. Okay, so, and then we will do that. The whole thing will be a return statement. The whole thing will say return this, get as whole, and if this does not work, get as symbol, get as symbol. Yes, sorry, yes, get a symbol, next char, and get a symbol would be get as yeah, otherwise get as ID or keyword. That's when it's a plain word. So it's either an ID or a keyword, and then all of that would go there. Okay, let's do it here. Private fun get as ID or keyword. Next char, and then we return a MathAsm token, and we paste all of that actually. Yes, that one. Else we just make that, we say get as digit. Else throw. That's it. What's your problem here? Get as a whole. What's ambiguity? What? I have it 2 times? Okay, all end of line, or if that does not work, try to get it as a symbol. If that does not work, try to get it as an ID or keyword. If that does not work, try to get it as a digit. And if nothing works, throw an exception. I think now the method becomes a little bit more structured. Okay, let's format this code. Nice. Okay, let's see if the tests still pass. Would be nice. Nice. We are good. Okay, let's commit and say, oh, first of all, let's make a branch. I will be doing, since I make this a live stream, I will be making 1 branch per episode, I think. Let's do that. So, let's write episode 2. Let's keep a simple branch. Names. Okay. And okay, let's do the rest from here because it will reformat the code of these files, and I like that feature. Let's say refactor. Or the most important thing we did actually support number parsing. Support number parsing. We did some other things too, but it was mainly that. Okay, and let's push it to the origin, and Nice. Okay. Now, let's return to the place that we would suppose to be called, which was the parser. The tokenizer is okay at the moment, so we move on to the hierarchy and we say, okay, who is going to call the tokenizer? Of course, the parser that should do the higher level job and parse statements, actually. Axiom declaration statements, theorem proof statements, import statements, export statements, whatever. This is going to be what will take control of the file. And it is parser implementation. Here we are. Okay, and this returns a parse result. That's our final goal, to read a MathAsm file and return one of those guys. And those guys would need a list of exported statements. Now, statements in this context, it means MathAsm statements, like basically theorems and axioms. This is what we're going to export here. And each one will have a name. We'll say if it's an axiom or not. We'll say here's the symbols on my left side, here are the symbols on my right side. Am I bidirectional or not, and what weight do I have? That's all. Maybe in the future we will return a list of errors. So if there are compile errors, parsing errors actually, or illegal MathAsm operations, whatever, we would return some feedback to the user. But this is not going to happen today. So that's a to-do, kind of. Okay. Now we have a tokenizer, right? Right, where is our tokenizer? Okay. So we get the reader and an executor. Yes, this is going to be the one who will make the magic happen. Okay, and maybe we will enhance this guy to have an implementation. No, not yet. Okay, and say that you also need to define axiom and define axiom would take, I don't know, the left side and the right side. Okay, let's write it to do. But we will have to define axiom, so we will call that guy. And then we will need to define something like that. Okay, I leave that to do because we're gonna step on it anyway, so there is no way we forget that. At some point we will have to call those functions. Okay. Now, the question is what we do. The first thing we do is create the tokenizer, of course. Tokenizer is tokenizer is tokenizer implementation. No, we don't have, we have one actually. Tokenizer, and we give the reader, and what do we give? Nothing. The reader, just the reader. Nice. So we create a tokenizer and we say, hey, give us your next token, right? So tokenizer, next token, next. Okay, now what can a next token be is the question. So when next token, let's go back to the notes that we had. No, not you. So it was documents, I think. Yes. The notes here. And let's see. Okay. A keyword. An axiom declaration statement, actually. If the next token is the word axiom, we know we have to parse an axiom. That's a valid case. So if next token is axiom keyword, then parse axiom. We get the tokenizer. So we will need to create that function. Yeah, here, please. And so tokenizer, next, and the next thing we expect after an axiom is the equals sign, nothing more. Like anything else is an error at that stage. Sorry, an identifier, of course. Of course. So we need a method actually that says expect identifier. Like I really need an identifier. If it's anything other than an identifier, just throw an exception. Like that's an illegal token. So after the axiom keyword, what we expect is an identifier. Let's see how we could do that. We could do that by creating a method here and say require identifier. And this returns an identifier token. How we call those guys? We call them identifier, really simple like that. Okay, I don't remember my own name, so that's a bad sign. Okay, so we return an identifier and we say next is yes, and say if next or return next as identifier, or else throw unexpected token exception. That's a different one. Expected identifier but found we have to implement toString, a series toString method for those guys instead. At the moment I'm too lazy to do toString, but all those guys should have a good toString method. This would very much help our parser be more user-friendly and create better error messages. So, yeah, that's pretty much it. So, here we would say name is tokenizer require identifier dot name. So we read the name, and then we expect an equal sign, and then we expect string opening, quote opening. Actually, that's not necessarily true. We can either expect that or that for the weight, but we will parse this. We will make this later. So, require equals. Yes. So, another good function. Yes, I think that's pretty much it. So we say we require a name and we keep it for later. We require the equal sign and we require the quote. And then we should start parsing symbols. Symbols. To parse the actual axiom. Okay, actually we will continue on that later. This is gonna be a point of work today, to start actually parsing axioms. But I would like to move a little bit back and say, what else could it be? It could be an axiom, yes. It could be an empty line in case, if it's an empty line, just continue, just move on, I guess. Yes. If it's an empty line, just move on. End of line. Then simply do nothing. Oh no, please. I don't want it like that. How we can write this in Kotlin? Just do nothing, you know? Yeah, my formatter is stupid, does that, which is really ugly. Is there a continue, simply? What's the problem? Yeah, I am inside. Ah, I'm not inside the loop. Ah. Yeah, we should have a loop actually. Of course we should have a loop. So, if it's like the whole thing, this should be in a loop. Also the next token. Okay. So we parse the next token, and if the next token is end of file, we return. We break actually. And if else, if it's not, we say is.parse statement. MathAsm statement actually. I mean, now, you know what, we are using the term statement in a bit ambiguous way. Statement means, and MathAsm statement, like an import statement, for example, that's a statement. And we say that this is also a statement, like a theorem or an axiom is a statement. Let's call those instructions. Instructions, like it's an import instruction, even though it's stupid terminology. Anyway, let's call them both statements for now, and I will try to figure a better name for them. Okay, so we need to parse the statement, and now this function would have all the cases. Private fun parse statement, we get the tokenizer, we get the first token. No, we don't need it. Ah, yeah, the next token. MathAsm token, and we just do whatever we do. So, if it's end of line, return. Yeah, so end of line means just nothing, there is no statement, there is an empty thing, just move on. And sorry. Yes, so parse statement, next token, and tokenizer. Yes, that's it. And yeah. Okay, so I need a break of 1 minute. I will play you some music and I'm right back. So it can be an axiom keyword, it can be an end of line, it can be an import statement, we don't have them yet. It could be a theorem. So if it's theorem keyword, we say, I don't know, parse theorem, which is going to be implemented, I guess. Maybe we could even move this to its own class and move this to its own class because it's gonna be big and I don't want this class to become a monster. Yeah, we will see. No, we will not see. Probably we will do it right now. So let's say statement, and we will create an axiom parser. So axiom parser, for example, and the axiom parser will get tokenizer. We will get the tokenizer, and we will have a parse method which gonna return the axiom data. Let's call them MathAsm, like axiom data, simply axiom data. And what is axiom data? I guess axiom data would be, again, left symbols, which is a list of string, and then the right symbols of the axiom. Actually, that's not an axiom data. This would be the same for theorem data, I guess. So let's call them MathAsm statement data. Yes, let's call them like that and move them to their own files. So statement and MathAsm statement data. It's a data class and it has all this cool stuff. So don't we have something like that already here? No. Okay, so val left, it's a list of symbols, so it's a list of string. Right also. In mathematical terms, these are the symbols that can be replaced by those symbols. So imagine that, I don't know, the symbols 1 plus 1 can be replaced by the symbols 3 minus 1, for example. Like those can replace those, and the other way around if it's bidirectional. So, speaking of which, is bidirectional, we need to know that it's a boolean, and the weight and the name. But I'm sure we have a class like that somewhere. Exported statement, yeah, that's what, oh God, we had this already. You see how stupid I am sometimes. Okay, so exported statement, it's here. In which package are we? Yes, exactly, it's our API basically. It's our API, of course. Oh God. So you go to garbage. We return an exported statement, an axiom. So parsable tokenizer, yes, we have to say that's a tokenizer in the type, and so this will simplify things. The tokenizer will simply say, not the tokenizer, the parser will simply say, if it's an axiom keyword, axiom parser parse, and we have to also give this guy yes. And now all this logic with all its complexity and ugliness will be here. So this class will be a little bit relieved from becoming a huge pile of crap. Okay. Proof executor, it's in the proof package, so I guess the exported statement should also be there. Okay, so here's the to-do, of course, and this is gonna be return proof executor. It's not actually proof executor only, it's more than that, but we will figure this out. Get exported or get statements, which is going to be a function that he will have, not abstract, it's going to be, no, it's going to be a list of exported statement, which I don't even like. I will call it MathAsm statement. So we are gonna get those statements and then filter it is public. We need to know that. So yes, we need that field, please create member property, yes. Here, please. Boolean, it's in the unit. Okay. Exported statements. Okay, it's not that bad, we can leave it that way. Return. Actually, this can be an extension function here. If we make an extension function, yes, okay. No. Let's write it the old school way. MathAsm parser result the exported statements. So that's what we're gonna do. Now, the axiom parser, when it parses the statement, it should call the appropriate methods of that guy, which is gonna be that one, define axiom. Define axiom. Actually, define statement. It's no matter if it's an axiom or a theorem, both would be the same thing. So define statement. Yes. So at the end, this should call that. No. And here should be the axiom we created. So just let's comment this out. And in the same way, this one would be, okay, let's copy that class and call it theorem parser. The theorem parser would be big. Theorem parser. And pretty much the same, after the keyword theorem, we would expect an identifier and then an equal sign. But not a quote. But not a quote. After the equal sign, yeah, here it's gonna be probably the most complicated, because we would have to parse all these teeny tiny expressions, and here then the dot and then the copy and then the parenthesis open, which has another expression inside it. It's gonna be pretty intensive, but we will make it. So this goes away now, and if that happens, we just create a theorem parser and we pass the tokenizer and the proof executor and we parse it. And if it's end of line, we just keep going and reading statements. So this would be an empty line statement, and then that, so do nothing. And then this would be an axiom declaration statement, and so on and so forth, until we get to the end of file, in which case our loop would detect it here, and then we would simply get our result and say thank you. Sounds like a plan. Okay. Now we should actually implement those two guys, and before we do, so else throw, let's do that, unexpected token exception. So if we find a token that we have no idea, it's not an axiom state, like unexpected start of statement, let's call it that way, statement start exception. Like we try to parse a statement, we had no idea what did you mean. Illegal statement start. And let's pass the token. No, it's not a function, it's a class. Don't you understand? It's a class. Oh my god, IntelliJ. I throw it. Of course it's a class. Oh god. Okay. So yes, please. Unexpected start of statement. And as we say, we need a good toString method for those guys, just to make nice readable error messages. Okay, so let's return to the unit tests of that guy, and let's see how many they pass and how many we broke. Okay, all of them fail. Yeah, multi-line comments are not supported yet. Oh boy, okay, let's fix that. That's the tokenizer again. You see, the tokenizer will never stop annoying us. Okay. So, is comment start? Yes, and then skip comment? Yes. Parse multi-line comment? Yes. So, while true. Now, well, next is this dot get next char. Next char. Maybe we will rename this to get next char because this is the convention we use everywhere else. Okay, so with get the next char, if it's not a star, we don't care because the comment, the multi-line comment will end with star and slash. So continue. Now, if it is a star, we have two cases. We read the next again. After star, character after star. And if it's a slash, it means the comment close. So return. Else, if it's not a char, it means somebody wrote a multi-line comment like that, and somewhere it simply had a star. Means nothing. Means nothing. You just continue. But the problem is if it's a second star, here we will have a problem. If it's a second star, you have to roll back. I'm pretty sure we have to do that. What's your problem? Yes. It's a char, okay. Yeah. If the next star is null, it means we reached okay, throw illegal end of file exception. And we will say end of file found while parsing token. That would be bad. Actually, the same is true for here. We should not, yeah. So, yes. Okay, let's copy that and write. No, you know what? Leave it. Just leave it as it is. Okay. So, if the character after is a slash, then return the comment is over. If it's another star, roll it back so the process continues. Else, just move on with your life. Actually, we could roll back always, because it's a second case. Let's try to do that. Let's try to do that. Okay. So now this test should pass, I think. I'm not 100% sure, but... No, still. End of file found while parsing comment. Which comment? Okay. If it's a star and then it's a slash. So, okay. Let's see that one. This is a multi-line comment. Ah, of course. That's correct. That's correct. Here it should throw. Of course it should. But this is a test for the tokenizer. Actually. Anyway, we should close the comment. We should close the comment, of course. That is good that it threw. No answer found for get statements. Yes, of course, we have to mock that. So, return empty statements. Okay, let's create that as a test util. That's a proof executor. Test utils proof. Okay, proof executor mocks. Let's put some mocks here, like fun proof executor, and then how we call that. Okay, so first of all, we return the same thing for chaining, and we say every, that's Mockito magic, every get statements returns empty list. But wait a minute, of course, now here's what we should be testing here. because otherwise, like, who injects this guy to the parser? We should have an implementation of this guy, right? Right. Okay. No, it's fine. It's fine. But in each test, then, we should see which of those methods were executed. Okay, let's see. Only one test is read. And unexpected token, underscore, yes, underscores should be allowed. Yes, that's a tokenizer thing. Or this is an underscore. Underscore should be allowed. Normally this should be test for the tokenizer, but yeah, let's be happy that we test this indirectly. Basically, this should also fail because our to-do will hit. An operation is not implemented, it's our to-do. Perfect, but we are at the point that we should start unit testing this thing, so it's good. Okay, let's commit everything we have and we say, again, we did a mess, like what did we do now? Many things, okay. Set up parser basic structure. Commit anyway. No, see the warnings. So, unused variable, yes, we will use it. Yeah, we will use it too. So, commit. Okay. Now, we should get an axiom. That's one thing. The axiom let's get another test for that. Should parse axiom name. So the axiom should have name is equal to some axiom, right? Okay, we can leave that. And then what else do we need? The right side, the left side, yes. Okay. Now those two will still fail. Our goal is to make them green. Normally we should go with one if we follow strictly TDD rules, but let's have two failing tests. It's not that bad. So we have to implement the feature necessary to at least parse the name properly. Okay, so we're testing axiom parser basically now indirectly, which is fine. We can say that statement is MathAsm statement, which we should create, and then the name should be the name that we write above, and then is axiom is true. Yes, we build an axiom where the axiom parser. Left side empty list for now. We will have to, of course, write the code for that. Is bidirectional. Let's hard code true for now. Wait, let's hard code 0. And public is true. Public axioms are always public. There are no private axioms. That would be madness. So, define statement. That one. What's the problem? Required found. What's the difference? Do I have that 2 times? Yes, and oh god, I have an interface too for that. No, thank you. Or should it be an interface? Maybe it should be an interface. Okay, let's make you an interface then. So let's put you on your own file. Yes, MathAsm statement, and you should have all these properties. Nice. So get name. You don't have the get name. Yes, and is axiom can be a function simply. Get left, get right is bidirectional, get weight is public, can be a function. Bird, don't be happy now. Okay, be happy, but not too happy, okay? Good. And you can be MathAsm axiom, which is a math. Bird, not now. Oh my god, bird happened. MathAsm axiom is a MathAsm statement. It's a bird. So, okay, now just implement the members. Yes, implement members, please. Yes, all of them, and we will see. Yes, name is the name, obviously. And then is axiom true, which means we don't need that parameter. That's the point, it's an axiom. The left will be list of string. Of course, it's gonna be the left side. And same for the right side. And then the way it's gonna be. And same for the is public. And same for the is bidirectional. Nice. Nice. Yeah, we need an interface because the theorems, and during the parsing we will need to create some abstractions for those guys because some of them are mutable, some of them are immutable. So the interface construct will help us, I think, even if it seems kind of like an over-engineering now. So MathAsm axiom, this is what we return. Okay, we don't need that. And we don't need that because they are always public. There are no private axioms. So let's move that on the top. Actually, here too is public, is important information. So actually we could merge those two to an enumeration of axiom, theorem, and private theorem. let's keep it with tupulants. It's not that bad. Okay, so we create this and then we define it. Of course, we need to parse the actual axiom, but okay, let's do it. Let's do it then. Left symbols, empty list, mutable list of, actually, we will put stuff inside of string, and the right symbols. And then we need to parse either that thing or that thing. Let's call that a bridge, like it separates, let's call it separator. It separates the left symbols from the right symbols. So it's a string. Yes. Nice. Actually, let's make that. Let's put that into a class. Let's put that into a class and call it private. Let's put the class here. Private data class, or simply class. Axiom parsing data. And then we put those inside. Left symbols, right symbols, and the separator is null, basically. Means we didn't read the separator yet. Okay. And we say val parsing, parse data, parsing data, yeah. Okay. Axiom parsing data. And then, okay, basically we just read quote opening. We will say while true, next token is basically tokenizer get next token. Next. Yeah. So this returns, okay, always a MathAsm token. So we have to check if it's end of file. If it's end of file, we should throw an exception and say, hey, we reached the end of file while we were reading an axiom. That's not normal. You probably forgot to close the string or something. So, okay, this is what we're gonna do. Right after a small break, more music, I'm coming right back to continue with this. My bird likes Rimsky-Korsakov. Yes, bird, yes, sure. Okay, wait a minute. I must take them the chicken. Okay. So, okay. If next token is end of file, throw illegal of exception. From the tokenizer, really? End of file found while parsing Axiom. Okay. Now, you know what? I don't like this. I will probably have a function, say, require not end, and then we return a MathAsm token, and then we put all that logic there to have it in one place. Yes, that thing. And say parsing label, and we will say end of file while parsing that, whatever it is. Good. Okay, so here next token this tokenizer, and then require not end, and we are parsing action. Good. So we got a token, and the question is, what is that token? To be honest, here we have a problem, because parsing things inside a string follows different rules than parsing things like here. Here, for example, this is an operator, and this is a different thing than here. But inside a string, everything is simply space separated. So we need a little bit different methods from the tokenizer, actually. Oh, the birds came. Hello, Tilly. We don't need that. What we need is completely different method. Let's say here, parse axiom symbol. So there are the following cases: that the symbol we read is a string, like anything other than this or this or this. Anything other than those things is considered a symbol, and we should return it. And if we find this character, we should consider this as the end of input, in which case we're gonna return null. Get next axiom symbol, let's call it that way. Okay, so we get the next char. If we don't find the char, we throw an illegal end of file exception actually. Where is this? Oh my god, this class became huge. Really, illegal end of file exception. I hope this is the last method we need to write. End of file found while parsing axiom. So here is our method. And if next char is the closing brace of the string, return null, which will mean end of input. Else, we do the following. We make a string builder and it has the initial char inside. While true, again, let's say that we need to read another char again. Okay, this becomes a little bit repetitive, but we will try to fix this. So actually we don't even need that. So maybe this will work. Let's see. So we get a builder and then we get the next char, not return break. So, and if we find that the next char character is this, we break. Otherwise, builder.append next char. And this happens again and again and again until if it's a string or next char is white space. If it's a string or white space, break. In this case, we should also ignore white spaces before that. Didn't we ignore white spaces again? Maybe we have a method called getNextVariable token or something like that. GetNextActiveChar, yes, here it is. The first time we need the getNextActiveChar. For all the rest we need the getChar. How can we solve that? Yeah, let's leave it to do. The first time we should call getNextActiveChar instead of getNextChar. Otherwise, we don't skip the white spaces before the thing. Okay. if empty null. Okay. And this is what this guy should call. And if you find null, it means end of input and simply break. So now we read a token from the axiom, and the question is, if parsing data has separator, no, let's say if next token is the separator, we will say parsing data dot set separator this. And we need to create this set separator and there are some business rules around it, which are you cannot have two times that. Like if you have one bridge here and one bridge there, that's not valid in MathAsm. There has to be only one and exactly one. So actually then let's collect them into a list. Let's, you know what, let's make our lives easy. Separators. That can be a val. So, or next token Notable list, unfortunately. So add next token. Else, if parsing data separators is empty, means we didn't find the separator yet, add the symbol to the next statement. Left symbols, add the next token. Else, add it to the right side. Means we already had the separator, so we are reading the right side. Yeah. All of that can be extracted to a method. Add to parsing data. That's better now. And yes, that seems correct. Then validate parsing data to figure out if everything was fine. And then parsing data, parsing data. Left symbols and then the right symbols. And then here we put the, yeah. Is by, let's create a function for that. And the weight is 0 at the moment, it's a to-do from our side. We need to be able to parse weights as well, but we will come to that. Okay, let's write a simple getter here. So it's a boolean, and it returns that this dot separators first or null is equals the three equals. If that's the case, then it's a bidirectional. If not, it's not. Okay, validating now the data. What we should do is the following. We should have exactly one separator. Throw legal axiom exception. An axiom should have exactly one separator. Either that or that. Let's create that exception. Nice. Okay, that's the one. Left symbols. If we don't have anything on the left of us, again, an action, or if any of those is empty, and no side of an axiom should be empty. Let's call it that way. And if these are not the case, then the thing is valid. And we can go ahead. And what's the problem here? That it expects to return something. MathAsm axiom. No, we just parse it, we don't return anything. Or should we? It would be easier to test. No, it's not gonna work for the theorem parser. Okay, yeah, that should be it. Normally we should be able to parse this. Get name is axiom. Let's see. What's the problem? Is public. It still doesn't work. What the hell? End of file found while parsing action. Why? Who called you here? Why end of file? Didn't you see that? Oh, I see. We probably didn't do that, that's why. So, next char is if builder is empty, the other one, else this one. Get the next active char. And then we will write if next char is null, throw your exception. What's your problem? That we can do that. Of course we can do that, yes. But it's ugly, you know, this parenthesis here and oh, it's already too ugly. Don't make it uglier. Okay, next are if that. Yeah, let's see. Maybe that was the problem. Still no. Okay, we have to debug, guys. Okay, so what's the next char? True, yes. And then we move to another word. Equals, yes. And then we move to another. Not, and then we move to another. False, and then it's the closing quote. So we should break, right? We should break. Yes, we did. Yeah, it's false. Exactly, and then we come again. Oh god, we didn't roll this back. We did not roll this back. So if it's a closing quote, we have to roll this back. So else if that, just break. Here also break. Roll back and break. Else if that, just break. Because next time somebody has to read that and understand it's the end of comment. Otherwise we just move. We consume too many characters. Okay, let's see now. Still not. Okay, good. We made progress. This happens much later, a lot later. So, our mock fails. It's not mocked. Okay, so define statement. We should capture that actually. This parser define statements. Okay. Mutable list of MathAsm statement. Yes, actually, let's make that here. Define statements. And we will be saying to that guy, instead of return empty statements, output statements to that list. Let's go and create that function. It's here, isn't it? Yes. No, it's here. Yes. Okay, every get statements return the list. What's the problem? Oh, yes, of course, get statements is a list of MathAsm statement, not axiom necessarily, obviously. And every defined statement, any, answers the list. Add this arg0. Just add it to the list. We simulate kind of like a realistic functionality, but it's still mocked. Let's see now. What? No. Who told you that? MathAsm statement. It's not necessarily an axiom. Yeah, dear. We don't need that. Okay, an expected start of statement. Let's see now. An expected start of expression, we got a quote. Start of statement, really? Okay. This is thrown by the parser implementation. Okay, so we don't close this properly. Okay. Here, something does not work properly. Yeah, okay, this I think I trust. Okay. True, and then the triple equals, and then not, and then false, and then we should get null and break. Yes. And the next thing that should happen, okay, until here everything seems correct. Now, this will do that and return, so we will return here. And then what is the next thing we get? Quote. Why did we return the quote? The tokenizer, no, the problem is here. We return the quote. If we find that, we roll it back so that the next time this happens. Okay. Yeah, that's a problematic part. Because we roll it back and then we return null because that's empty. Let's try to do that. But we faced another problem then. So we face a conflict here. Oh good, parsers are... Writing a parser is challenging. Okay. So the problem is that end of file found without, yes, the problem is that we parse this and then we return whatever token we found. How can we solve that issue? Okay, I want to understand what happened. So the problem here is we try to parse first of all this thing here. So we return false, skipping the token. And the next thing we see is the end of file. So it crashes. Because we should roll back this and then it should see this and say, hey, that's the end of the axiom, and then move ahead. So it's a misunderstanding between this guy and this guy. Because white space means continue reading the axiom, it says that the token ended. And this one means stop reading the axiom, actually. So this should not be treated equally. That's definitely the case. Here is axiom stops, and here is symbol stops. Axiom continues. So, in this case, we should return that, I think, not break. But yeah, breaking also returns that, so that's not really making any difference. In this case, we should return null. The problem is we should roll back and return null. The problem is no, we should not roll back. We should return what we read, because sometimes you read something like false closing quote, something like that. So we should return that and roll back this character. This makes sense. This makes sense. Okay, I think I found the solution. We will roll back the character, but when we return here, we will read the closing quote again. Tokenizer.require end quote, and then go ahead to the next command. So this is what should happen. Let's see now. Boy, yes! Finally. Finally. Okay. Okay, guys, we read axioms. Let's create some tests to be sure. So, should parse axiom symbols. We say 1, 2, 3, and here we say A, B, C. So we get 1, and then the right contains exactly 1, 2, 3. And yes, that was the get left, and the get right contains A, B, A, B, C, D, F. Why not? We will write it like that to be sure that it can also pass characters. And you know what? Let's create weird symbols. Let's put something like that, and then something like that. So symbol should be read like that. It's only white space separated. And let's make it even more difficult and add some more white spaces here. So this should work. It doesn't. Actual A, B, C, yes, D, F. Yes, works. Yes. Okay, should parse by directional separator. Bidirectional axiom. Let's call it that way. Okay, let's simplify that. Let's remove that and do that. It's bidirectional actually. And we should also be able to pass single unidirectional we call them. So this should be a unidirectional axiom. Let's call all the tests. It doesn't. Yeah, of course, it is false. That's the point of the test. Yeah, of course. Good. Code is good. Test is wrong. Nice. Good. What else? Should give weight 0 by default. So get weight should be true. Is equal to 0. Sorry. And axiom should produce public axioms. Good. Yeah, but is public is what you test. Wake up. Guys, we are parsing axioms. That's not that bad. That's not that bad. Okay, let's create something more challenging. Should parse two axioms. So we should parse two axioms. The first one should have name some axiom. I'll say first axiom, or even better axiom 1, just to test also that numbers work. And the second one should be the axiom 2, which we're gonna write. Okay, let's put 2 empty lines just to test also that we're having 2 empty lines. You know what, let's make a multi-line string, since Kotlin offers this possibility to us. Nice. Let's change the axiom too, and let's try to do that. And I will also put an empty line in between. Yeah, now we don't need the escapings. That's also a difference. And nice, we parse axioms. Isn't that great? Okay. That's a to-do from our side. Support larger weights. And that's all with axiom parsing. Actually, let's commit. Yeah, that's not ready yet, of course. But we almost have the axiom parser ready. Let's support the weights too now. Let's support the weights. After the equal sign, we will write val weight this dot read weight. And here we have the following options. Read or skip weight. So let's create that, and we don't return, we return an int, which is a weight, basically, and we get the next token. This tokenizer next, and when next token is quote, if it's quote, directly return null, return 0. It means we directly found, after the equal sign, we found that. It means we are in the default case, weight 0 by default. That's like writing that, the same, just the default value. Then second valid option is to find this. Is do we have that? Actual symbol bracket open is bracket open. If it's bracket open, we break. Yeah, we don't have breaks here, just right. Yeah, how to say do nothing, just that. But yeah, the formatter will do it like that. Oh my god, it's difficult. Okay, we will put that code here inside. Else throw legal axiom exception, and let's say expected quote or weight such as but found next token instead. Okay, if it's a bracket open, then number is this tokenizer require number. Let's go and write that. Tokenizer, where is it? Here it is. Require number token, expected number, but found that instead. Dot value, right? Yes. If number is less than 0, throw illegal axiom exception, weight cannot be negative. Okay. And then this Tokenizer require bracket close. And then also require quote. This is how it should work. I don't want to call it number, let's call it weight. Yeah, do that. Okay. Now we support the weight. Okay. Let's run the test just to be sure that we didn't break anything. And then we can write a couple of tests with weight. Nice, all the tests are passing. Actually, let's write that here. And should parse weight axiom sum axiom 2 is like that. Get weight should be 2. And let's write one unit test that by default weight should be 0, or did we write this already? Get weight. Yes, we have it there. Okay, let's see if we can parse weights. Okay, that failed. Unexpected token. Expected equal but found bracket open. Really? Where did you find the bracket open? Ah, yeah, of course. Yeah, that's correct. Here it goes. Yeah. Oh boy, it's working. Support weight in axiom expressions or axiom declaration statements. We make progress. Now we can completely make sense of such statements. We can completely parse those guys, which is good. How much time? Oh, it's 2 hours already. Okay, I'm pretty happy for today. We have the Axiom parser. It's unit tested. It feels like running good. And the next thing would be to make the theorem parser, which is gonna be maybe trickier. We will see. Lily, you want to say hello to the internet? Okay, so let's make sure we have pushed everything, and now let's go to let's put that plane. And let's go to GitHub and create a pull request for that. Here it is. Good. The reason I do it in GitHub and not directly in Git is because I like the squash and merge option. Maybe it's possibly Git, but I don't know really how to do it. So let's say, yeah, it's trivial. It's only for the Git history. So let's simply go ahead and merge it with squash and merge. So that's it. Yes, please. Nice. And now let's see how the Git history looks like. Yes. So the master branch we'll have one commit. That's the merge commit, kind of, right? Yes. Nice. So if we want to travel in time, we can just travel one commit of master, and it's one episode behind. Great. Okay, guys, thank you very, very much for being with me today. Let's close it. In the next episode, probably I'm gonna concentrate on theorem parsing. So we will be parsing things like that. And calling the necessary functions that will do the transformations. We will not be implementing the actual logic of the transformations. That's going to be the next step. I want to focus a little bit on parsing the text and then write the business logic around this. What I wanted to do also before is at least have the syntax for the import statements and define symbols like that, imported symbols. So that's all. And then we're going to be in a good way to actually create a parser that scans the file system, reads all the MathAsm files, and then outputs the theory in a database or something. Okay, that's all. Thank you very much, and see you in the next episode.